My name is Olga Padilla-Sacor. I'm a professor in food science in our department at Cornell University, and it's my pleasure to introduce our speakers today for our webinar on modern drying technologies for value-added food and agricultural products. So we're going to divide the session into two parts. The first part will be covered by Professor Chan Cheng, and then the second part will be covered by our processing authority, Elizabeth Sullivan, from the Cornell Food Venture Center. We will have an opportunity at the end of the webinar for you to ask questions, but we'll also be monitoring the chat. Just in case there are questions, you can actually write them there, and we will be monitoring that too. In time allowed, we'll answer as many questions as possible, but you also have the opportunity to direct the questions to us via email. You see the emails right now on the screen for Dr. Chan Chen and Elizabeth Sullivan. Thank you very much. It's a pleasure to have you all here today. And Dr. Chen, please start the information for us.
All right. Thank you, Olga. Good morning, everyone. It's very nice to have you. And we're very happy to share some of the drying technologies. And like Olga says, Lisa and I will cover different aspects. We'll start with fundamental principles of the drying, and we'll talk about food quality and how to measure them, and then move on to the drying technologies and demonstration of some equipment that you can use. And then Lisa will cover the critical control points that's on the safety and the regulation side. All right. So throughout this webinar today, we hope you will have a better understanding of the drying principles and the mechanisms, and you'll be able to recognize some of the key quality attributes related to your food and how to measure them properly. We hope you can compare some of the major drying technologies, have a better idea to know which one is the best for me, and to identify the regulation needs and the critical control points. And overall, we hope this will help you to make decisions and that impact your product's success and the cost of your process. All right. I guess for everyone that's registered for this webinar, you must know why the drying matters, right? Because the foods, from the fruits to vegetables or meats or grains or cereals, they all have a lot of moisture in there. So they make them not very stable. So to extend their shelf life, availability, we need to remove the moisture by drying, and more specifically, to reduce the water activity. Besides the quality and safety side, drying also help you to allow the lightweight distribution and reducing the transportation cost, because you do not have to pay for transporting the water. And the dried foods can be consumed directly or used as high-value ingredients, such as powders or making into snacks or ingredients. And nowadays, consumers are looking for more of the functional properties of the foods. So the drying should also consider how do we preserve the probiotics, the phytochemical and bioactive compounds, and retain them and preserve them in the foods. Drying seems to be a very mature and easy practice, but actually the industry is facing a challenge to do good drying. You have to balance between the safety and quality, and also consider the energy use, because the margin of the dried food is not as high as some of the pharmaceutical or other products. So it plays an important role in the cost and also the sustainability. So without further ado, let's move on to the first section on the drying fundamentals. So what is a drying? From a unit operation or an engineering perspective, drying is a process that removes the water from the solid via heat and mass transfer. Now, the heat transfer is a process that provides the energy needed for the drying process. From the engineering perspective, there are three different basic types of the heat transfer modes. The very first one is called conduction. So this is the contact heating. If you're not familiar, I want you to consider this scenario. So you're putting a piece of cold meat onto a hot pan. This is the conduction. Convection is the second type of heat transfer. And this is very common in your hot air drying ovens when this forced air is to circulate around the food and heating up the food and taking away the moisture. The last one is radiation. And the radiation heating is actually very common. So consider the sunlight that we have every day. And nowadays, there are more direct devices that delivers the infrared heating and also microwave heating to heat up the food more efficiently. Now, mass transfer is another process that governs the moisture migration from the food internal to the surface and also the evaporation. So internally, this happens as a process known as diffusion, while the convection is the process at the surface that's taken away the moisture evaporated from the food surface. To perform proper drying in a good practice, it is important to understand what is the drying kinetics. It is actually a study of the drying rates at different stages. Now, if you look at the figure on the left, this red curve shows a typical temperature increase trend during a food drying process. And the dark blue curve shows the moisture content change. Now, in almost all of the food drying process, the process can be separated into 3 different periods. The very first one is called the preheating period. This is usually when the food temperature starts low, and then as it's getting higher, the moisture is being activated and then being removed. But however, the moisture removal actually in this very first stage is relatively insignificant because of low temperature. But once you reach to a certain temperature, then the moisture, and you have abundant moisture, particularly the free moisture in your food, the drying rates become significantly higher and kept at this constant level for a period of time. And so this is called a constant rate period. So then moving on to the third period, this is usually the longest among all the 3. And this is called the falling rate period. As you can tell by the name, the drying rates keep dropping until the end of the drying process. This is because after the constant rate period, the free moisture is not that much in the foods, and so a lot of moisture is still in the foods, but has high binding energy with the food matrix. So it takes more energy, it takes more resistance to remove them and migrate them from the food internal to the surface. That's why the drying rate declines. At the same time, the food temperature continues and until the end of the drying process to a level similar to your heating temperature. Now, drying is all about moisture. So let's get familiar with some basic concepts. You probably have heard about a concept called moisture content and water activity. Probably don't know what's the difference of them. So they're all about moisture, but the moisture content is actually all the moisture that exists in the foods. But not actually all of this moisture are active or can be used for microbial growth that happens during the spoilage or quality degradation that's involved in some biochemical reactions and water. So the water activity is a measure of this active part of the moisture within the food. And so it has a value from 0 to 1. Now, when we talk about drying and control, there are some key water activity thresholds that we should pay attention to. First is 0.85. This is the level that stops the microbial growth, particularly the bacteria. And 0.6, this is the water activity level that significantly slows down the quality degradation and also all the microbial growth, including the bacteria and mold and yeast. Scientifically, this is supported by this diagram shown here. So this one basically shows the relative reaction rate of that can be growth rate or chemical reaction rate related to quality and safety degradations. So as you can see from the dashed lines here, below 85, you have the growth of bacteria almost stopped, and below 0.6, the growth of the mold and yeast almost stopped. But at the same time, the quality aspect does not, the impact of the water activity goes longer. So you can still have the over drying and under drying process. So the reason why we need to perform good drying practice is to have the best efficiency and also the quality preservation. All right. There are actually so many different factors in general that can influence your drying process. From the operating parameters perspective, temperature is a very common one, right? A higher temperature can accelerate the drying rate. But at the same time, when your food has high biotic compounds that are thermally reliable, they can have the nutrient loss. Air velocity can enhance the heat and mass transfer rate, so increase the drying rate. Air humidity is very important and is usually neglected because it's not easily controlled. But it's actually the gradients difference between the humidity at the food surface and your environment that is the driving force of the evaporation. So if you have a hot and dry air as the input to dry your food, it can dry much more efficiently compared to a cool and humid air. Pressure of the environment is another factor from the operating perspective. You may have heard about the vacuum drying process because the vacuum can significantly lower the boiling point of the water. So this allows the drying to happen at a much lower temperature. And this is particularly useful when you are dealing with foods that are thermally sensitive, so allows the efficient drying at low temperature. Besides the operating conditions, the structure and the properties of the food itself also plays a very important role. For example, a thinner sample with a very large surface area favors moisture evaporation compared to a thicker sample with a smaller surface area. And to achieve good practice and achieve the critical control point of the quality and safety perspective, sometimes you will need the pre-treatments. For example, meats need to be cooked, a lot of vegetables need to be blanched, or even freeze or partial dehydration, or use other treatments such as the pulse-electric field to improve the safety and also the drying rate. Now moving on to the second section on the quality attributes. We're going to talk about some of the very common and consistent quality attributes to different types of foods. We'll start still with water. We have talked about the water activity and moisture content, but how do you measure them? In a standard method in the industry and also analytical labs, we have this desktop version of water activity meter from Aqualab. But the critical or expected water activity values, it really varies by the product. For example, the USDA will require you dried meat products like jerky to have water activity lower than 0.85. But with a chewy, soft, dried fruit, the water activity can be as low as 0.6. But if you want to achieve a crispy texture for a snack, for a chips, then the water activity needs to be lower than 0.4. But for powders, this should have to go even lower, 0.2 or below. Now, moisture content measurement, the most accurate way and standard method is by gravitational method in oven drying. So as you can see, you can use 105 degrees Celsius and dry your food for 24 hours. This temperature is slightly higher than the boiling temperature of water, which is 100 degrees Celsius. And this will allow the full drying and of the food without causing any other quality degradations or volatilizations. But in some cases, if your food contains these active compounds that can evaporate or can degrade and then cause the significant mass change, then you can also use a vacuum oven drying method at lower temperature at 70 degrees Celsius and keep tracking of your sample weight until the sample weight does not change between the two adjacent measurements. But this standard method takes time. So if you're in a practice and just want to have a quick check, you can also always use this halogen moisture analyzer as shown on the left-hand side of the bottom row of pictures. So this use a halogen heat lamp to quickly heat up and dry the food with a significant small amount of samples, usually in a powder form. And so you can have a measurement quality, a moisture content measurement within 10 to 20 minutes, depending on the types of food and the moisture content. In some cases, you are dealing with more on the grain or cereal or corn side, you can always also use the electroconductivity meter. For example, this shows here as a John Deere moisture tester. It correlates the moisture content of the cereal with the electroconductivity. But I want to mention that this is also a quick check only, and this is not considered the most accurate method. It can usually give a quick measurement within a minute, but it should be noted that electrical conductivity of the food is closely related to the chemical composition besides the water. So it needs to be calibrated carefully with each types of the food you are measuring. And also the packing density is very important. A loosely packed and a tightly packed foods in the measuring chamber can give you very different results. So if you have the capability, we would definitely recommend to use the almond drying method for the moisture content. Coming up next is the texture analyzer. So if you're a small processor, if you just want to do some empirical testing by snapping your chips or ban it, you can definitely do that. Actually, that's what the almond industry in California is doing to determine the endpoint of their drying process. But if you want to achieve accurate control, precise control of your texture of the product, you should use this quantified and scientific texture analyzer. By performing some of the comparison or puncture test, or if you can also do the tensile test to have the tensile strength, depending on the types of the products. Color measurement is very important, and this is just because the color is actually one of the very first and direct quality attributes the consumers look at when they decide if they're going to buy a product or not. If you're a small processor, there are more of an empirical way using these types of the visual scales. They're also available very cheap and also available for the color blindness groups. But a lot of the larger companies can also use a higher end colorimeter that give you a quantitative measurement of your color matrix in different color space. For example, the Konica Minolta portable colorimeter we have here measures the L star, A star, and B star under the CIE lab color space. Rehydration ratio is another type of quality attributes that are important. This is when you're dealing with quick meals or vegetables for soups or breakfast cereals. So basically, this measurement involves the soaking a known mass of your sample within a known volume of water and allow it to stay in there and track the time, track the weight change across a period of time. So this will help you to get an idea of how fast and how much of the water can be gained from your dried food. So in some cases, even if you control your drying practice, the quality defects is still inevitable. So here we summarize some of the common quality defects and the cause of it to help you understand what kind of situation you're dealing with and potentially how you can address it. The first case is the case hardening. This is usually related to a hotter drying process or a process when the food experiences significant shrinkage during the drying process. So this is when the moisture is removed and the solid matrix cannot withstand the stress caused by the drying and then shrink and clump together. And this is also more significant when you use a much higher drying temperature and the high sugar content fruits. In the case of the fruits, the sugar can be dried and crystallized on the surface and cause a very hard case that can even slows down the further drying process. And darkening and browning is very common in the food drying, and this can happen at high temperature drying or even low temperature drying scenarios. For the high temperature drying scenarios, this is usually related to the Maillard reaction that's happening between the reducing sugar and the free amino acids within the foods. But if you perform a poor temperature control and let your food to be overheated and at very high temperature, you can also induce the caramelization of the sugar or even carbonization and that cause burning. In some cases, you may encounter this scenario. I didn't use a very high temperature, but my food still get browned. What happens to it? And this is because of enzymatic browning. And the enzymes are types of molecules within the fruits and vegetables and almost in all different types of foods that naturally exist in there. And it catalyzes some of the biochemical reactions that convert the bright color the pigments into some darker colors, and by oxidation or the degradation of the molecules. And what you can do to mitigate this is to perform good blanching control. This is particularly for your leafy greens, or if we're dealing with bright color fruits and vegetables, to use a hot water dipping blanching or steam blanching can significantly control the enzymatic browning. Sometimes you have the loss of the crispiness if you're dealing with a crispy snack. So it can be two scenarios. First scenario, the food becomes soggy. This usually indicates that you performed a bad water activity control. The water activity needed to have crispy texture is not rich. So measure the water activity is very important. And or this is probably because a poor packaging that allows the dried foods to pick up the moisture from the environment. And this becomes very significant in this part of the nation because we have very high air humidity levels, and the dried foods is not actually is not in the equilibrium, but if you do not have a good packaging, so it absorbs the moisture. In another case, if you're drying a chip, it becomes hard and glassy. And this is particularly significant when you have a lot of starch or sugar in your food. And like we said before, in the case hardening case, this sugar can crystallize or experience glass transition and becomes very hard and dense, and resulting in a texture that is not very favorable. When you are in the powder space, stickiness and caking are very common issues. And this is because the powder has such a high surface to volume ratio. So it's very easily and readily available to pick up the moisture from the air. And this becomes very even more significant when we're dealing with the fruit powders, instant fruit powders, or lactose-free milk powders. And this is because this kind of powders contains more monosaccharides or simple sugars like glucose or galactose or fructose. So this type of sugars have very low glass transition temperature, and then when they absorb the moisture from the air, they form a state called a viscous state and becomes very sticky. And so this not only affects the product quality, the solubility, but also even directly affects your drying yield, which we'll cover in the spray drying section. Now, with all of the quality measurements introduced, let's look at some drying technologies for different types of foods. Before we jump into the very first one, let's say how can we dry the foods? So in the normal condition, the water exists in three different phases at different pressure and temperature. The solid portion is known as the ice, the liquid is water, and the gas is the vapor. So by playing with the temperature and pressure, we can directly evaporate the water from the liquid to the gas while vaporization, or directly from the solid to the gas through the sublimation process. So this actually the pathways that give rise to the variety of different drying technologies we are going to introduce today. So the very first type of the drying technology is hot air drying. So one of the most commonly used and easy to use method nowadays in the industry. By principle, it uses hot heated air to remove the moisture by the convection. And the advantage of it is relatively low cost overall. It's very easy to handle and scale up or scale down. As you can see, it's widely available in different formats. Some examples shown down here. The left one is the tunnel dryer that uses hot air to dry the stone fruits such as apricots or prunes in California. So this, as you can see, these are almost 10 meters long drying tunnels. They're very large capacity. The middle one is a very generic tray dryers, can be used for almost anything. In some cases, you can have the large drying bins, and this actually is a drying bin using hot air for the walnut and other tree nuts in California. The limitation for the hot air drying process, as we indicated a little bit before, is the shrinkage and also the long drying times, because the mass transfer by convection, its nature, is not very efficient. And if you're using a high temperature to accelerate the drying, you may have the browning issues. So how to lever between the quality and the efficiency is actually very important. And what you can control with the hotter drying process is control your temperature, your air humidity, and the air velocity. Now, as we mentioned before, hotter drying, even though it's very commonly used, the long drying time may even cause more energy consumption, right? And this becomes a significant portion if you're dealing with a large volume of foods. And then the energy consumption can mean a lot to your operating cost. So what are the methods we can use to lower the energy consumption and improve the drying efficiency? One of the options is the heat pump drying. So consider this is an upgrade to the traditional hotter dryers. What it does is it uses additional refrigerant to cool and condense the water from the exhaust air of the dryer, and then extract and recycle that part of the heat and recirculate that to the inlet of the dryer. And because it's the heat recirculation, you do not need to provide as much primary energy to the dryer. So this allows the energy saving. But at the same time, because the water is removed from the inlet air, it allows you to do humidity control, and that significantly reduces the drying time. So heat pump dryers have been used in some advanced cloth dryers and room heating or AC, and is also available in the food space. Now let's take a look at an equipment demonstration with a video that our grad students prepared on the heat pump dryers that we have at Cornell.
Hi, and welcome to the series on Cornell drying technologies. Today we will be covering the hot air dryer. So the hot air dryer is one of the most commonly used pieces of equipment in the food industry, and it uses fans to blow hot air across the surface of food products. This forced convection causes water to evaporate off the surface of the food and also leads to the diffusion of moisture from the inside to the outside. So when you use the hot air dryer, you will load product on the trays on this cart, and then you will push this cart into the machine where you'll close the door and leave it for a predetermined amount of time until the drying process is complete. And this process usually takes a few hours. So when operating the machine, you will set the relative humidity and the temperature inside the chamber, and also determine the amount of time you want to leave it in for. Some important things to consider when using this machine are the orientation of the product on the trays. It's important to have adequate spacing so that you have even and efficient drying rates. And you also want to monitor the color, texture, and moisture content of your product to ensure it's at the quality that you want.
Great. So next piece of technology we're going to introduce is the spray drying. As we mentioned, spray dryer is mainly used for liquid drying and the powder drying. So what you do is you have a feed of a concentrated liquid fit into the drying chamber that it atomizes through a spray nozzle into very fine liquid droplets. As it drops down through the drying chamber, we also provide a hot air flow that either in counter flow or the concurrent flow scenarios that allows the very fast drying. So the drying temperature is usually between 90 degrees Celsius to 180 degrees Celsius. So it's extremely fast, depending on the scale of your dryer. It can be from seconds to minutes. So from the quality aspect, it's very important to control the stickiness. Conventional way is to add a high glass transition ingredients into it. For example, maltodextrins are commonly used, gums or fibers. But in the current space, consumers are very careful about the added sugar into the feed. So the scientists are also looking for other options to do that. From the operating perspective, it is important to control the temperature at the inlet and outlet. Given that the spray drying has a relatively short retention time and it's a continuous process, this temperature selection can significantly affect your flavor retention and color as well as the yield. Now let's look at a process demonstration.
Welcome back to the Cornell series on drying technologies. Next, we will be covering the spray dryer. So the spray dryer is used to convert liquid solutions into powders. And so a liquid solution would be fed into the top of the machine through a tube where it meets a piece called the nozzle. The nozzle is used to atomize the liquid solution into tiny droplets with the help of a very hot inlet gas. This gas is used to evaporate the water off of the droplets, and so only a solid powder is left. The solid powder then falls to the bottom of the machine where it is separated from the gas using a system called the cyclone, and this evaporation occurs in seconds. So when you're operating the spray dryer, you will set the inlet pump speed, the atomizing gas pressure, and the chamber temperature. When using the machine, it's important to monitor the quality of the powder that's being collected at the bottom to make sure it's being dried properly. It's also important to pre-test how the powder dries to make sure it doesn't caramelize or get sticky, and this can be done with something like a handheld hot air dryer before you move on to spray drying. Spray drying is also not suitable for high fat or temperature sensitive products since the hot temperatures inside the chamber can cause fat oxidation or lead to the degradation of compounds. And finally, if the powder is not dried properly, it can build up on the sides of the walls of the chamber, which will decrease the yield and also can lead to a sticky final product.
Next piece of the drying technology we're going to introduce is called microwave vacuum drying. So this is a very emerging drying technology. It has shown great potential to use for the value-added snacks, fruit and vegetables, and also even the medical cannabis and hemp. So by principle, the microwave vacuum drying use is similar to our domestic microwave ovens. So it uses a magnetron to heat up the food. But once the door is closed, the whole chamber is put at high vacuum. And as we know, the vacuum lowers boiling temperature of the water, and this allows the drying to happen at close to or slightly higher than room temperatures, but at a very fast rate. This is because the microwave can penetrate the foods and allows the volumetric heating, and that significantly increase the drying rate. But if you can control the drying process very well, you can also achieve puffing of your food without using the oil. This is usually achieved through the deep frying. So one of the examples is showing down below here is a moon cheese product that is pure cheese that's produced using the microwave vacuum drying. Compared to the hot air drying, microwave vacuum drying also retains the color and the volatiles much better. So it can reach to clear, close to the freeze drying scenarios. The current limitation for the microwave vacuum drying is a batch process, but there are also other continuous commercial scale microwave vacuum dryers available. So it's a very promising technology.
Welcome back to the series on Cornell drying technologies. Today we'll be covering the microwave vacuum dryer. So this is a microwave vacuum dryer. It combines heating through microwaves and also vacuum drying. So vacuum drying allows for the boiling temperature temperature of water to occur at lower temperatures. So this can be a good process to use if you have heat-sensitive compounds. Additionally, it uses microwaves, which volumetrically heat food through radiation. So when you're using this machine, you will load your product onto Teflon trays that rotate. And this is because Teflon is invisible to microwaves, so only the food product itself will be heated up. Additionally, you have to rotate the product because microwaves create standing waves. So if it did not rotate, there would be hot spots and very uneven heating. So after the product is loaded onto the trays, you close the door and pull the vacuum, and the product will be left for the desired amount of time. After the process is up, you will release the vacuum using these valves, and then you can remove your product. The microwave time depends on the product that you're drying, but typically varies between minutes and hours. So when operating the machine, you will set the time, the total microwave power or wattage, the vacuum level, and the critical temperature. Throughout the process, you'll want to monitor the temperature so you don't exceed the critical temperature because the process will shut off. Additionally, it's important to know or have a good idea of your initial and final moisture contents and weight so that you can predict your parameters properly. The microwave is an instance where you really want to know your parameters before you start, as you cannot see inside the machine during the trial.
The last piece of drying technology we're going to cover today is the freeze drying. So by principle, you need to freeze your product first. And then once the products are frozen, we load them into the chambers shown here. And then the whole chamber is put at a high vacuum and also maintained at a low temperature. So allow the water to be evaporated through the sublimation process directly from the ice to the gas vapor. So freeze drying is a very popular technology now because it's considered as one of the best technology to maintain the nutrients and the shape of the foods, almost the natural shape with minimal shrinkage. And so this is lead to a product with very high porosity, and this is good for the rehydration. The limitation of the freeze drying process is a relatively slow process. Depending on the types of food you are dealing with, it can be 24 to 48 hours or even longer. And also because the whole process, the whole chamber has to be under a high vacuum. So you need to maintain running off a vacuum pump as well as a condenser to maintain the low freezing temperature. So this means the operating cost is a little bit high. So it has been used on the premium snacks, high-value foods, prebiotics, and also NASA used it for the astronaut foods.
Hi, and welcome back to the series on Cornell Drying Technologies. Today we'll be talking about the freeze dryer. So this is a freeze dryer. It relies on sublimation to remove water from its solid form as ice to its gaseous form, and this is how the product dries. So freeze drying is used to create very high-end and high-quality products, as it is a more expensive process. And this is due to the fact that it takes much longer than other processes like hot air drying or microwave vacuum drying, because freeze drying takes around 12 to 24 hours, whereas the other methods take minutes to hours. So when operating this machine, you will set the shelf temperature to be cold during the freezing step and warm during the drying step. Additionally, you'll set the condenser coil to be colder than the shelf temperature. You also set the vacuum pressure and the time in the machine. This is an instance, again, where product spacing on the shelves is very important. You want to maximize the contact between the food product itself and the shelf so that you can get even freezing. You also want to make sure that the product is completely frozen before you move from the freezing step to the drying step. So when operating this machine, you will set the shelf temperature to be cold during the freezing step and warm during the drying step. Additionally, you'll set the condenser coil to be colder than the shelf temperature. You'll also set the vacuum pressure and the time in the machine. This is an instance, again, where product spacing on the shelves is very important. You want to maximize the contact between the food product itself and the shelf so that you can get even freezing. You also want to make sure that the product is completely frozen before you move from the freezing step to the drying step.
Great. So we have talked about this 5 different types of technologies. I'd like to give you a summary table for comparison. Except for the spray dryer, it's mainly used for liquid feed and powder space. All the other 4 types of dryers can be used for almost all types of products. From the quality perspective, freeze drying and micro vacuum drying can give you the premium quality, while hot air drying has the limitations, but also if you can properly control the process, will also give you very good quality. From the energy perspective, heat pump dryers, because they use the circulated heat, it's on the lower end, while the freeze drying is on the higher end for energy consumption. And that's directly related to the operating cost. From the throughput perspective, currently hot air dryers and heat pump dryers are the best because they can be made into continuous mode. But the next generation of the micro vacuum dryings is also continuous in large scale, so it's very promising. Besides the operating cost, you should also consider the capital investment of the equipment. But it also really depends on the types of the equipment you use and the scale of it. So it's a mix between the capital and the operating cost. Now I'm going to transfer it to Liz to talk about the critical safety and quality attributes.
All right. So the biggest thing to keep in mind when you're talking about low water activity foods and dried foods is that the water activity doesn't actually kill pathogens. So a lot of pathogens, a lot of spoilage microorganisms can survive at low water activity. They don't necessarily die. They won't grow, but they won't die. And the example I would give here, the biggest one, is the peanut butter outbreak from 2007, 2008, where we had poorly dried, poorly stored ingredients, and we had a lot of post-process contamination. There were actually holes in the roof. And this was actually contaminating that peanut butter product. When you've got poorly dried and poorly stored products, you can also get mold growth, and the molds will sometimes form mycotoxins depending on the kind of mold you've got. And the example that I would give here is drying grains. If you don't dry them properly, you can get aflatoxin production. So for drying processes in particular, good manufacturing practices are absolutely vital. Next slide. So pre-drying, right? Your ingredients have to be clean. They need to be sanitized. You want to think about cleaning first. You can't sanitize unless you clean. So you want to wash your produce if necessary, then do any peeling or cutting necessary, and then do your sanitation step with a chemical sanitizer. You may also think about doing a blanching step. This is to destroy the enzymes, which Chang talked about earlier, but is also to destroy pathogens. So dipping vegetables in hot water, for example, or boiling water treatment to pasteurize the surface. It helps to really influence the cell walls, break them down a little bit so that drying might be easier, and again, destroys those enzymes. The sanitation, the blanching steps, those might be critical control points because they're ways that you're controlling your biological hazards, that microbial control. Next slide. All right, your drying time and temperature may also be critical biological hazard control points, depending on the product pH, depending on the drying technology you're using. If your product pH is above 4.6, you have a low acid food, that initial drying step, if it takes place at temperatures above 135, that's okay because we don't have microbial growth at that stage. Until you get that water activity below 0.85, which is the threshold for pathogen growth, or we're going to control that temperature time to less than 4 hours, because we want to control the amount of time that the product is temperature abused, where we could get microbial growth and specifically pathogen growth. Some very typical water activities that we talk about for pathogen control would be 0.91. So below 0.91, you don't have Clostridium botulinum growth. Below 0.85, you don't have any pathogen growth. And of course, below 0.60, you don't have growth of microorganisms at all. Your time and temperature, much like your drying time and temperature, these may be requirements for your commercial sterility as well. And it's more likely to be the case that it's a critical factor when you have a water activity greater than 0.86. I'm sorry, 0.60. All right, next slide. Okay, so controlling those biological hazards. Again, we want to talk a lot about good manufacturing practices and controlling your cooling and conditioning steps. You want to control the conditions that will allow the growth of microbial spoilage, molds, for example. You want to control the conditions that will allow for bacterial growth. One of the things that you need to think about is your processing and packaging environment. What is your factory air like? Do you have a high humidity environment? Is that going to be a factor in post-process contamination? Are you drying your product and then actually rehydrating it because the factory air is too humid? You want to think about packaging. Do you need a moisture barrier? Do you need oxygen control in order to deal with these situations where you may have more humidity from your factory air? So again, we're controlling the growth of microorganisms, but we're also controlling quality issues such as rancidity. We're controlling the storage conditions as well, the humidity, the temperature, things that might lead to rehydration of your product, but also lead to quality issues. Okay, a couple of regulations real fast. All of this drying is covered under the FDA FSMA regulations in the Code of Federal Regulations, Title 21, Part 117, which is the preventive controls for human foods. There's a very similar thing for animal foods. GMPs are listed specifically in 21 CFR subpart B. For the USDA, there is a meat jerky guidance. So the picture there in the bottom right-hand corner of your screen, that's actually the meat jerky guidance from 2014. That's free online. You can look it up if you need to. As part of your dealing with FSMA requirements and USDA requirements, you may need to validate your drying equipment. Make sure that it's working properly. You'll have to keep records of all that validation work. And any reports that are issued. How do you know what factors to control, your critical control points? Those would be given to you in a scheduled process. Sometimes they're also found through peer-reviewed literature, particularly if you're using USDA and your product is under HACCP. Next slide. The last thing here for regulation, all foods are under labeling rules. So FDA has labeling rules. They have a labeling guide that's actually quite good, free online again. The USDA has its own labeling rules. They have a food standards and labeling policy book. This is free online. You can look at it. And all foods, we're concerned about allergens and we're concerned about heavy metals. So a lot of this, the heavy metals in particular, will be controlled by your ingredients. And I think that's the end of this section, Chang.
All right, thank you, Liz. In this last section, we'll give you some practical tools and some takeaways as a wrap up. As we introduced before, for good drying control and practice, you need to care about your quality and also environment. So you can have one of these portable water activity meters that help you to give quick readings of your product's water activity. You can have one of these quick moisture analyzers for quick check. And as Liz introduced, the storage conditions becomes very important your post-harvest storage and handling conditions, particularly the temperature and humidity is very important. So having one of this digital hygrometer with loggers to control and record the humidity and temperature of your air conditions, and also to have a good drying check sheet to mark the start and the end point of your drying process can be very important. In terms of decision making, how do you know which drying method is the best for you? So we would suggest to ask yourself these questions: what types of products are you drying, and can you name the top 3 quality attributes that matters the most to you? And think about, is this type of foods very thermal sensitive? So that will help you to determine the room or the flexibility of the temperature you can use, and then select the drying methods. And also consider what type of throughput you need. Are you a small processor? You're not dealing with a lot of materials, or are you having a cost limitation and a target? So this can play a role in the decision making of a drying technology. But still, if you're hesitant and to get these devices, or just don't know which one is the best for you, we are here to help. At the Cornell Food Venture Center at Agritech, we provide service on scheduled processing, as Liz mentioned. So actually, besides Elizabeth, we also have Dr. Olga Padilla-Zicker and Dr. Bruno Zerier, who are also process authorities, can do your scheduled process. And we have a whole team to support you to do product testing. And also, as you can see from the bottom right corner, we have the Seneca Foods Foundation power plant housing these drying technologies that you see in the video demonstration. And we can have you to visit and do process development and validation, and to help you decide which is the best option for you. Now, here is some resource of the links. You can take a screenshot, and then later on we'll transfer this webinar into a video for you to share on the website. And we hope this is helpful for you. And we also have a quick poll for you to give us some feedbacks. If you don't mind, it will pop up now. And with that, we would like to thank you for listening, and feel free to provide questions.